All right, next question here, question 4. I would say that this starts actually as a really quite a tricky question. Draw on the diagram will help you for sure. Let's have a quick read. So electric cooker, simplified heating diagram, fine. All 4 elements are switched on at full power. Okay, so that would be all of these switches are closed. So it's running all of them at once. The hob draws a current of 26 amps. Right, so what that means is 26 amps is going to be drawn through here. And the voltage of it is 230. So this is 230 volts. Or at least that's its average value because it's an alternating voltage. So, find the resistance of just one heating element. Right, so I've only got to find the resistance of one of them. So let's have a look and think about what these numbers mean and how we can label these numbers on. So if that 26 amps goes in, have a think. How much current is going to go through each resistor given that 26 amps is going to come out the other side? 26. Okay, so I got to think about this. It's 26, but it's dividing through 4 paths. So 26 divided by 4, I don't know why I'm calculating that, 6.5 amps. So basically, each one of these is 6.5. Now, think about the voltage. Imagine that we've got a potential here of 230 volts. Then that means that the potential right before the resistor is 230 as well. Now, on the other side, the potential over here is 0 volts. Maybe I should do these in a different color so we can see the voltages in red. 0 volts, 230, and then 230 down here. Well, that means that on the other side of the resistor, it's 0 volts here as well. So I know, and I'm going to draw my own little sketch of this now. I know that if I have one resistor, flowing into it is 6.5 amps, and the voltage across it is 230 volts. Well, write down what we know. If I've got the current and I've got the voltage, I can get the resistance. So, let's solve. R equals V divided by I. So 230 divided by 6.5. I do need my calculator for this. 35.38. 35.38 ohms. But check the question. It says give it to 2 significant figures. So the final answer is 35 ohms. Each one is 35 ohms. Okay. Then it has a table. I'm not going to read it all. But it says that the wires, the usual power sockets, are 2.5 mil squared copper wires. And that would give me a voltage rating of 20 amps. Well, how much does my cooker need? Well, my cooker needs 26 amps. Okay, so how can we phrase this? We could say 2 marks, 2 bullet points. Current drawn by cooker is more than 20 amps. So what will happen to a 2.5 millimeter squared wire will overheat. And I think that's the best phrase you could give. I mean, yeah, it might melt, it might catch fire, but basically it's going to heat up too much. So overheat is kind of generic and implies that it's going to melt or catch fire. Part C, what's the difference between AC and DC? So alternating current, 2 marks, 2 bullet points. AC changes direction. And that's happening constantly, right? It's got a frequency of 50 hertz. It's constantly changing direction. DC is always in the same direction. Is always in same direction. A couple of people here talked about alternating voltage and said like, oh, the values can be positive or negative. But it is asking about the current, so we need to make a reference to direction.